Electronic Specifier.
Welcome to Electronic Specifier Insights, the podcast for electronics engineers. I'm your host, Paige West. In today's episode, I speak with Rob Moffat, Deputy Director of Sales and Business Development for Europe at MediaTek. Now, as I'm sure you know, the mobile gaming industry is constantly developing, and with close to 4 in 10 people using their mobile for gaming, mobile gaming is set to be a significant and expanding area within the broader gaming industry. So, I chat with Rob about the role of semiconductors in the future of mobile gaming innovation. We hope you enjoy this episode. Let's get started.
Electronic Specifier.
Hello everyone and welcome back to Electronic Specifier Insights. I'm pleased today to be joined by Rob Moffat, who is the Deputy Director of Sales and Business Development for Europe at MediaTek. So, hi Rob, thanks for joining us. And how are you today? You well?
Very well, thanks Paige. Yeah, thanks for inviting me on. It's a pleasure.
Good, you're very welcome. Why don't you tell us a little bit about yourself and your background?
Sure. So yeah, Rob Moffat. I am from Scotland originally. I went to university in Glasgow back in the days of the 90s. Did computer science as a degree, so always been technology focused. And then after university, I was looking for a role. All the stuff near me was pretty boring in the banking industry, so I looked further afield. I landed in the south of England in the mobile phone industry in 1996-97 with Panasonic Mobile. So I was a software developer there. I worked on software development in mobile for around 10 years or so, then switched to looking after customers like the mobile operators within the handset guys. And then ultimately, after almost 10 years at Vodafone Group in the UK, I moved to MediaTek. So it became obvious that the chipset industry was playing a significant part in where the technology in the industry was going. So I thought I was interested in that. And I've been at MediaTek almost 10 years now. So yeah. That's my journey.
And for those listeners who perhaps aren't familiar with the company, why don't you tell us a bit more about MediaTek as well?
Yeah, sure. So MediaTek, we're a global fabless semiconductor industry. So we design but not manufacture mobile chipsets as well as other chipsets. So we are, I think, the 5th largest by revenue globally as of last year. We've got around 50 offices globally in multiple countries, over 21,000 employees at this stage. We're headquartered in Taiwan. So in Hsinchu, in the science park, where a lot of the semiconductor industry is based. And last year, the revenue was around $14 billion. So a good year last year. And the business is split into 3 main areas as we categorize them. So one is mobile phone, so mainly smartphone, but we do still ship feature phone chips to some regions. One is power ICs for power management, and the other is everything else, if you like, we call Smart Edge. So Smart Edge covers everything from tablets, Chromebooks, connectivity, fiber, automotive, as well as ASIC design. So 3 main parts of the business. And I'm responsible for the mobile business in Europe.
Fantastic. And obviously that's the part we're going to focus on today. As I'm sure you know, and as I'm sure you will tell us, the mobile gaming industry is constantly developing. And with close to 4 in 10 people using their mobile for gaming, which I didn't realize, it's set to be sort of very significant and expanding. So I'd love to discuss with you the role that semiconductors are going to play in the future of mobile gaming innovation. So from your perspective then, what advancements in semiconductor technology have had the most significant impact in mobile gaming devices?
Yeah, there's so many, right? I mean, it's like a system-wide evolution that's led to the improvement in the gaming industry on mobiles. As you say, right? I mean, over 2 billion people worldwide gaming already. We've came a long way from, very basic games on Nokia Snake all the way through to real-time online games at this stage. On the semiconductor side, there's so many areas. One of the key ones, of course, is the graphics capability in terms of in the chip, right? So with advanced mobile GPU, so the GPU being the key part, obviously, for rendering, where the GPU is these days, we work closely with ARM as our key partner for our GPUs. And, the ability to drive higher frame rates with the same power curve, because power efficiency is key, is important in that GPU. And, bringing the latest graphic rendering technologies into the mobile space has been key in the last 2-3 years. So, things like ray tracing is key. So in our high-end devices we'll talk about later, maybe we brought in ray tracing. So GPU is key, but, it's the whole system-wide compute capability. So we move the whole system forward in terms of CPUs, so multiple cores, large amount of capability and compute, as well as we have NPUs. We have called the APUs in the past, so basically AI processing units on the device as well, all playing their part, including in the gaming aspects we can talk about. But outside of the actual cores and the compute, we have the users are looking for high-end displays and resolution. So, if you look at a device today, we have to drive display technology beyond 4K in terms of resolution. So, that's driven by the SoC that we provide. And you have to support, users expect really high refresh rates. So, to get your smooth gaming experience, you need to be above 60 hertz, definitely, towards 120 and beyond. So, currently we'll support up to 180 hertz refresh on our flagship devices. So, the advancement in display technology and driving those displays is key. And the other one, of course, is connectivity. So, we've seen a generational leap in connectivity in the past 3 to 5 years. In my side, I'm focused on cellular. So, 5G is a significant advancement and it enables so many of the use cases in gaming. But outside of 5G as well, we're a strong proponent of Wi-Fi. So we now support Wi-Fi 7, for example, tri-band Wi-Fi 7 on flagship devices to ensure the user, when he's not on cellular, has the best experience possible in terms of connectivity. And, beyond that, Bluetooth is still a key technology. It doesn't get much of the headlines these days, but the latest Bluetooth specs and the support we have is key in driving that wireless, especially the audio wireless capability for spatial lossless audio, right? So those are all driven by our kind of packaged SoC. So, all of those advancements have made it possible to get to where we are today with high quality and almost console-like gaming on devices.
I guess, how do you balance the need for the high processing power with the challenge of maintaining sort of the battery life in mobile devices, especially for gamers? They're using their phone for gaming, but also for everyday use as well.
Yeah, I mean, it's the ever constant in our mobile chipset design, right? There's not a lot of tolerance, as you say, no matter who they are on your device. For a smartphone, it doesn't last at least a day, right? So it's constant for us, no matter the use case, to try and design power efficiency from the ground up. But it's difficult, as you said, they expect high performance as well. So, one of the key things is the production process for the chip. So our manufacturing partner, in most cases TSMC, it's important for us to be on the leading edge in terms of the production process with those guys, because the new production processes bring automatic benefits in both areas, right? They bring increased power capability in terms of power efficiency, but also increased performance. So recently we announced our new chip. We're on the 3 nanometer, the second generation 3 nanometer from TSMC. That's important because on a like-for-like scenario where you're running all the cores on the chip, we're seeing a 40% improvement across some of the benchmarks. So that's just from moving to the new production process. So, that's key because that brings that balance of capability alongside power efficiency. The other one is the architectural layout, of course. So, you have to pick the highest components in terms of that performance. So we made the decision maybe 2 years ago in our flagship devices to move to an all big core solution to drive that capability, especially in the gaming scenario. That's probably the most intense scenario where you see the cores being utilized. So we've gone for the latest generation from ARM. So again, it's about working with the ecosystem. We partner with ARM for their power efficient cores, of course, both along the CPUs and the X series, along the GPUs with the Immortalis GPU and in the NPU side. So, we work very closely with ARM to try and design power efficient cores and solutions. And, the other key area is the peripheral areas, things like memory. So it's very, the memory on the device is crucial. How fast that memory can respond to the requests in the gaming is crucial. We've worked with Samsung to support the new DDR5X technology. So you get 10.7 gigabits per second throughput from the memory. So again, that makes everything much more responsive. But the reason that's important is it comes with 25% power efficiency versus the previous memory generation. So everything we've put into the new flagship devices is taking power efficiency into mind. And of course, it's not just in the AP side of the chip, as we call it, in the application processor side of the chip. It's also in the modem itself. So it's often overlooked, but when you have cellular connectivity a lot of your device power drain is because you're talking to the network, of course, constantly talking to the network. So, we've built a suite of tools called UltraSave, we call it, which is basically taking the standards-based power saving features that you get from 3GPP, who control the 5G specifications, but also building some proprietary algorithms in there, so to try and reduce the power drain in terms of what's happening in the modem side. So with that, we're seeing between 15 and 20% reduction in the modem power drain, like for like, generation on generation. So again, it's often overlooked, but trying to drive that power down in the modem side is something that's crucial for us as well. So yeah, the whole system plays a part, but it's about having the right ecosystem, working with the right partners who always have power efficiency at mind from the design up, and that's where we are.
And you've mentioned 5G. I mean, can you tell us a little bit more about how that's changed the landscape for mobile gaming? I'm thinking particularly in terms of, reduced latency and faster data speeds.
Yeah, absolutely. So, for those of us who've been on mobile phones for a long time, we've gone through the challenges of 3G and 4G data connectivity, I think, especially in the UK. One of the key pillars of 5G was what they call EMBB, Enhanced Mobile Broadband. That's effectively the part that mainly addresses the smartphone space. So yeah, it comes with three main parts, right? One is the higher speed, so faster data throughput. So as you say, the key thing for gamers is if they're going to download games, then they should come faster, right? So the download of the game itself and additional DLC content for the game should get to the device quicker in terms of the 5G specs versus 4G, of course. The other key thing, though, is because of that speed, developers are able to build bigger games, if you like. So, there's less of a barrier to entry in terms of having a much larger game because, the download speed, even in cellular, is going to be acceptable in the 5G space. The second area, as you mentioned, was low latency. That one's obvious. So single milliseconds latency is key, right? Especially for real-time gaming. There's very little tolerance for that. I've got two boys who... one's no longer a teenager, but they've played online gaming for a long time. They've gone from casual gaming, puzzle-based, to real-time gaming. They have no tolerance for lag on the device, whether they're on Wi-Fi or 5G. So that low latency is crucial in terms of making that, single-player shooters or whatever multiplayer online as key outside of the Wi-Fi environment. And the third area was high bandwidth. So not for the individual device, but when you're in a crowded environment, whether it be an urban environment or whether it be a transport environment or whether it be a stadium environment, being able to have multiple devices connected to the 5G network and not have a degradation in quality is key as well. So they've all assisted in terms of making the gaming experience better. The other area, though, is cloud gaming. So, we tend to focus on games physically installed on the device. But obviously, cloud gaming has taken off in the last 3-4 years or so, especially with ecosystem guys like NVIDIA and Xbox cloud gaming, and that allows 5G allows you to have a cloud gaming scenario where you take all the hardware needs on the device effectively away, because what you actually need is a strong connectivity solution to stream the game in real time to the servers on the other ecosystem partners back end. So cloud gaming is one of the key enablers from 5G space. It allows you to be potentially connected to cloud gaming on the move rather than just static at home on a Wi-Fi connection. So, that's where 5G's really helped in the gaming space, I think.
Are you having conversations about 6G at all, or is the focus still on 5G? Sorry,
yes,
I had to ask.
Yes, we are. Much to a lot of people's disgust. So yeah, we're very active in the standards bodies, as you can imagine, and yeah, we've already got some white papers out there in terms of 6G vision and where it could go. I think we've still got a way to go as a mobile ecosystem on 5G before we get to the 6G scenario, right? So in terms of the next phase for 5G, in terms of the overall ecosystem, the deployment, especially in Europe, I guess, as UK and Europe, it's not really caught up, right? So the standards have got all these cool stuff there, and we're not there yet in terms of what's out there from a network perspective. So, and that has an impact, especially on things like latency and specifically for gaming, right? So today, most, if not all of the networks, especially in the UK until this year, probably have been on what we call non-standalone 5G. So it's dependent on, you've got a 5G radio network, but it's actually hooked up to the 4G core. So that comes with inherent disadvantages in terms of performance. There's advantages in terms of speed of rollout, of course, which is why it was done, and cost. But for the end user, they don't really care, right? They want the high performance. So I think as an ecosystem, we'll see the move to standalone 5G. Some people call it true 5G, right? So it's been around for a long time. We've supported every one of our 5G chips from the very first one. We support it from our lowest 5G chip up to the top. So once true 5G standalone is rolled out, that'll come with some key benefits, right? So, quality of service should be improved because of the latency improvements, because you've got a full 5G core. We've already seen trials from some of the operators because standalone allows you to basically give you a network slice. So you can slice the network and give some guaranteed quality of service for different use cases. One of the ones that we've seen trialed is a gaming slice. So basically you can offer guaranteed bandwidth and quality of service for a gaming scenario using that slice, and the rest of the network is there, but that slice is optimized for gaming. So that's very important. And the other thing is the area of 5G that's not out there with NSA non-standalone is the ultra reliable low latency communications, URLLC as they call it in the standards. That's mainly targeting things like remote surgery and factory automation. But there's another key benefit there, which is another bump in latency improvement. So again, that could come for free when you get to 5G SA from a gaming perspective. So I think we've got a long way to go before we get to 6G. We need the ecosystem to catch up with standalone 5G rollout, and then we'll see some additional benefits for the users though.
That makes sense. And something else you mentioned earlier as well is ray tracing, which is considered a major innovation in graphics technology. So why don't you tell us a little bit about how MediaTek is integrating ray tracing into its mobile processors and what it means for mobile gaming?
So, ray tracing is key to the gaming experience in terms of realism, right? So all the nice graphics you see on our console grade high-end AAA game, ray tracing plays a key part in that rendering and in terms of realism on the display. Until maybe 2 or 3 years ago, from our perspective, that was software-based best effort ray tracing. So you were limited in terms of the software capability that was running. And we moved 2 years ago. We worked with ARM, and we brought the first hardware-based ray tracing into our chipset line for smartphones. So that was the previous generation Immortalis from ARM. So, we work closely with ARM to optimize that. This year, we've launched our second generation using the G9 series of GPUs from ARM, the Immortalis G925. So we will be landing that in our flagship chipsets. So it's not in every product at this stage. It has impact in terms of cost, of course, but also in terms of die size and compute requirements that are there. So at this stage, we'll put it in our premium flagship products. That's where the expectation is as well, alongside other key technologies that we've already discussed in terms of bringing technology leadership. So, we'll bring ray tracing. We have ray tracing already. We brought it this year. The key thing really, though, again, is the ecosystem and partners, right? So it's great having the feature on the device, but it only works if you have developers and gaming houses bringing mobile-based ray tracing games to the market. So, as part of that, we've got an SDK, a ray tracing SDK that we provide to the game houses. And we work with some of them in terms of directly on case studies and optimization of that. That SDK obviously gives access to the Vulkan APIs, which is a key one for ray tracing across the graphics community. So, what it means for us is it's tight working with the game houses to try and build the ecosystem up in the mobile space. There's quite a few games out there taking advantage of the hardware ray tracing. For me personally, nowhere near enough. I don't think when you see what's possible in terms of the realism, in terms of the shading and the lighting and everything that comes with it, and the number of games taking advantage, there's still a big mismatch at this stage. So, a large part of it is trying to build the community in terms of driving that. For us, it's a key technology to bring more realism to the gaming community alongside the other technology pieces. But second generation will continue to build the ecosystem with our partners.
Are there any other sort of key technologies that you see on the horizon that will help benefit mobile gaming?
It's very tricky. There's some advancements of ray tracing, if you like, that bring some additional benefits. So, there's a feature called opacity micromaps, OMM, which basically, it allows you to render better visual details, finer details, without adding too much complexity to the model and the rendering. So, OMM is one which will make things even more lifelike in terms of people's hair, in terms of, seeing vegetation and stuff in games. Things like mirrored surfaces, OMM adds to that, again, a bit of more realism. Don't really want to talk about AI, probably. Everybody wants to talk about AI, but, we can't get away from it. Variable rate shading is another feature that we see which could be used more. So that allows basic AI-based variable rate shading allows you to basically focus on what is the key focus area of the game in the frame and focus the compute and the rendering on that area and maybe not pay as much attention to the other one. You can do that via AI now in the AI VRS solution. We'll work very closely with ARM on that, ARM super resolution. So I expect to see some iterations in that super resolution features in the coming generations from the mobile GPU space. Beyond that, not so much, to be honest. We're limited by obviously physical size on the device, which means you've got the, die area is one thing you need to consider in terms of the, deployment. And then obviously thermals play a key part in terms of technical challenges on the device, right? So yeah, it's a challenge.
Yeah, I mean, that leads nicely onto my next question, which was, I was going to say, what are some of the biggest technical challenges that you face as a company when designing semiconductors for mobile gaming?
Yeah, the key restriction is really physical space. Tablets, okay, maybe you're on a larger tablet, but the majority of people gaming are on smartphones, so 6.7 inch or below in terms of display size, and the smartphone manufacturers want their device to be edge to edge, so it's not 6.7 inch plus another big lot. It's 6.7 inches is the max. So we're limited by, the key limitation is physical form factor, and then within that, you have, given the extreme compute power we're seeing, right, running large cores over 3 towards 4 gigahertz. Thermals is one of the considerations you need to take into place, right? So, there's many things that come into that. Obviously the power efficiency we talked about, making sure throttling is limited, but it goes back to even the fundamentals in terms of the hardware and the packaging, the manufacturer. So, we've worked on some unique packaging in terms of physically packaging the SoC to try and improve, and we've seen great results in improving the heat dissipation. So we've got a new packaging scenario to improve the heat dissipation from the chip when you're running in extreme scenarios, which is mainly in the gaming space, as I said. And what we've seen with that is, for example, going from 20 degrees on the device as it ramps up towards 90 degrees. By having this packaging, it contributes to us like slowing that down by 4 times. So 4 times longer before you get there in terms of that temperature. So, the packaging is very important. The other challenge is game responsiveness for the user. It's not just about the hardware. So we built a suite of engines called the MediaTek Adaptive Gaming Technology, which is MEGT. It's a MediaTek acronym, but basically it's taken what Google have built in the Android ecosystem. So Google have a framework called Android Dynamic Performance Framework, ADPF. And what that is it allows all of Android basically real-time access to apps and games, to allow real-time access to what's going on in Android in terms of the overall system. And it provides that game and app with hints and tips about how to optimize the performance. So everyone on Android has that. So, it tells you to maybe modify the resolution, maybe modify the frame rate, the resource loading changes. We've gone beyond that and we've worked closely with Google on this. So our MEGT, since I think 2021, we've had an SDK available for game developers to allow them to fine grain and tune on a Dimensity chip, one of our chips, that real-time scenario. So basically, it can prevent severe throttling. So we give much more information on what's going on in the chip to the app in the game, and they can make decisions to kind of modify the game and try and improve it. We've seen some case studies where we've seen consistent frame rate improvement of like between 8 and 9 frame rates per second by utilizing the MEGT technology to prevent the throttling. So, that's very important. It's a suite of engines that touches things like picture quality. So we've got pixel level motion blur to make sure the blurring isn't there and the picture quality. Obviously, we get the ray tracing SDK we've already touched on. We've got a resource management engine to basically stop jittering in games to stabilize it. So that's about balancing when you're using the GPU versus the CPU and the NPU. We've got things like a networking engine in there. I'm not going to go through all of them. We'll be here all day, but we've got a networking engine in there which allows, it balances the coexistence of different technologies like Wi-Fi and cellular in the same band and cellular and Bluetooth to make sure that, the handovers are good between the different technologies and that there's a latency reduction there. So the challenge is both hardware and software. Hardware in terms of design and packaging, of course, and thermal dissipation, optimizing the design for the form factor, alongside working closely in terms of with ecosystem, Google in this case, and beyond for ourselves with the game companies to give them access to real-time access to what's going on in the chip to try and optimize the game real-time. So, these are the main challenges. There's one more challenge, though, that I just wanted to touch on. It's a physical challenge, which is how users hold the device. So especially in the Wi-Fi to a certain extent, Wi-Fi and cellular, but whether you're holding the device in portrait or landscape means your hand is covering certain parts of a smartphone in a given way. And as part of that, there's multiple antennas in the device from the manufacturer. And depending on where the hand is, then you could be impeding the antenna performance because you're covering the antenna. So especially if you switch to landscape, then you may have both hands on the device, covering the back of the device, covering the antennas. So, we've worked on this for a long time with our smartphone partners and internally. So it became even more apparent when we moved to flip and fold devices. So it's another physical scenario where they could be using it in a whole different manner with the kind of half-opened flip device. So, we've got an antenna control system, which basically takes in information from like proximity sensors on the device into our antenna management software and basically makes a decision using various tuners about which antennas are the best to use at any given time and what level they should be running at. So, it's very low level stuff, but it's very impactful. Again, in real life scenarios where we've run this in labs with some partners, both smartphone partners and operator partners, we're seeing a 3 dB improvement in terms of they are in 30% throughput improvement in terms of on the device. So like for like, going from that scenario without our antenna tuning control, then turning it on, we're seeing a 30% improvement. So that's another physical challenge we see, right? It's one that's easy not to think of, but that has a direct impact on the performance.
I never even knew that was a problem. I'm going to have to go and experiment now and see how I hold my phone and if it makes a difference.
Yeah, exactly. Yeah.
So given all you've said then, how do you see the hardware requirements for mobile gaming evolving over the next, say, 5 years?
Yeah, I don't see any revolution, to be honest. I think we're going to see iteration in terms of where we're at. We'll see new improvements from basically inheriting from the console industry, right? So where possible, when the form factor doesn't restrict it, I think we'll see continued improvement in terms of the rendering and the taking advantage of ray tracing in that regard. I think AI is going to be one. It's going to be important to have dedicated AI silicon, which we have on our 8th generation, but having an NPU, APU, as we've called it in the past, because I think I know we're going to start seeing AI having an impact on real-time gaming on the device. So, I think most people foresee a scenario where, AI's got its place to play in terms of game development, of course, which is outside kind of the remit for us. But in terms of on device, I think, there's a scenario where you have the NPU potentially impacting the real-time game where the levels are modified to take advantage of the user's personal behavior, where no two levels are the same. Everything's optimized for the device with the generative AI that's capable on the flagship chip. So I think we'll see a need for more and more AI capability on the devices that maybe not obvious to the user in terms of the AI use cases we see, like assistants or that kind of thing, but actually in the background working with the GPU and working with the rest of the rendering engines to make games improvement. So I think that's going to have an impact in terms of we'll see improved GPU in different product tiers. Today, to be honest, most of this sits in flagship tiers. So, as the users expect better and better gaming performance for lower cost devices, then I think, we'll just see the standard waterfall effect of a lot of those coming down the tiers in terms of NPUs, in terms of Immortalis GPUs. So I think it's going to be iterative rather than revolutionary in the next couple of years. Cloud gaming we touched on already. I think cloud gaming is really in its infancy in many areas until we get that 5G ecosystem to be robust. So no real impact on the hardware in that regards. I think what's missing in 5G that kind of chipset vendors don't support today. The only things really left in 5G are, again, about power saving. So there's some kind of very detailed, unique features about reducing the power with the network, but nothing that's going to impact the hardware there. So I think the hardware side, in terms of the radio and RF's kind of done at this stage on 5G. Then it's more about maybe the user side of AI.
What about augmented reality or virtual reality? I think we had a buzz around that for the gaming consoles, but do you foresee a future where people are utilizing that technology for mobile gaming, and how is that going to impact the processors?
Yeah, I think so. I mean, very, very different, I think, in terms of if you look at the impact on the processor. So, you're right, AR, right? I mean, let's be honest, when was Pokemon Go? Probably 8 years ago, maybe.
Yeah.
I mean, that's quite a long time ago, right? Pre-pandemic. Yeah. Pokemon Go was the next big thing, and people were out on the street catching the Pokemon. So, it's obviously the best example of what could be done in terms of AR and enjoyment and entertainment. There's not been much since then that's really grabbed the gamers' attention. There's AR apps out there, but nothing that really is kind of broken through to be wholesale kind of entertainment. So there is room there. And in terms of the impact on the processor from an AR perspective, there's no real, again, it's about the tier of the device. But in terms of if you take, what's expected on a premium device today, don't really see a big impact on the AR side. In terms of what's missing, I think, is the content and the games rather than any impact on the processor. One of the key things for AR, of course, is camera and rendering. Camera, we've not talked about camera, but the camera capability is key in AR, and that's something we've also worked on separately in terms of moving camera capabilities forward, as everyone has. So I think everything's there in terms of the camera capability and all the other aspects for AR. VR is more challenging, right, in terms of the compute power and what's needed there in terms of you're rendering a whole virtual environment. So we've worked on VR outside the mobile space. So it was MediaTek. We had multiple ASICs in the PlayStation VR2 unit. That's kind of the most high-profile one in recent years, where we've worked with a partner on VR. So we had a lot of learnings there, and some of that can come into the mobile space. But I think the compute power that's required for VR is really the challenge, and I think we're still quite far away from that. Again, there's kind of some VR scenarios already where you can use your smartphone, but again, I think they're limited, right? So yeah, I can definitely see a future where AR and VR will be having an impact on our mobile design and mobile processor design. At this stage, not so much. It's just kind of part of the overall package in the AR side. VR, we've still got a while to go. We've got, obviously, you've got the Apple devices, you've got the Meta devices out there in terms of standalone VR devices. Whether they've been successful or not is up for discussion, but they're there. I think we're probably a good few years away before VR breaking into the mainstream.
I don't think the price point is there at the minute, is it? I mean, the headset is very expensive.
Yes, prohibitively expensive, right? We talk in the mobile space. We talk about expensive in terms of flagship smartphones, of course, are touching £1,000, of course. But yeah, you're another level if you go to a full VR environment, right? You get the headset, you get the controllers, you get everything that goes with it. Then yeah, it's very prohibitive at this stage. And part of that is of course is mainly the hardware, right? And a key part of it is the processor. It's mainly ASIC design, so it's dedicated custom silicon for those partners. So that comes with cost increase, of course.
Yeah, definitely. No, it's certainly been a very insightful conversation. So thank you for your time. Was there anything else that you wanted to add before we wrap up?
No, I don't think so. I think we've covered most of it. I think from our side, we're trying to put the building blocks in place for the gaming community on the mobile devices that we think the end consumer wants to see. And we work closely with the ecosystem, whether it be on the design of the components themselves, whether it be with the software ecosystem, working with Google and the different frameworks. And also, as I say, key working with the gaming studios. So yeah, I hope to see more high-end games soon.
Yeah, so do we. We'll certainly watch this space. So thank you very much for your time and for your insights. It's been a real pleasure speaking with you.
And with you. Thanks for your time. Thank you.
Thank you for listening to this latest episode of Electronic Specifier Insights. Don't forget to subscribe to the series to keep up to date with our newest guests, and do share with fellow colleagues, friends and family who may be interested in the latest news from the electronics industry.
Electronic Specifier.